Okay, question 17. The ceiling of x written, well, that sort of ceiling looking thingy, I suppose, is defined to be the value of x rounded up to the nearest integer. Okay, that's a very common operator in mathematics as well. For example, the ceiling of pi is 4. Makes sense, right? Because pi is 3.1 something, so the integer above it is 4. And so on and so on. Yeah, the examples are self-explanatory, I suppose. Okay, the key thing is that the ceiling of 8 is still 8, yeah? It's not 9, remember. Okay, it's not 9. Cool. And of course, the opposite of the ceiling is the floor. Right, we have the floor in other MAT questions or maybe TMUA questions as well. So, look for those. What is the value of the following integral? You're going from 0 to 99, 2 to the power of ceiling of x. Okay, I've done these sort of questions lots on my channel already. You know, when you see some dodgy functions which you don't know how to integrate, what do? You draw a diagram and then think about the area under this graph. Right, so off we go. How do I draw this diagram? Well, let's start from close to 0. So if I have a number very close to 0, then the ceiling of it would be 1, right? So I'll get 2 to the 1, right? So between 0 and 1, my value, so this is my function here, all right? This is the x here, okay? My ceiling looks very weird right now, but you get the idea. It will be 2, right? So my graph is flat here. Okay, how about between 1 and 2? The ceiling of any number between 1 and 2 is 2, right? So 2 squared is 4. Okay, so my function is here, 4. All right, or let's say 2 squared, because later on it's more convenient to use 2 squared. Okay, and so on, right? And you get the idea. When it's between 2 and 3, then you have 2 cubed, of course. Yeah, this is 2 cubed. I don't have space to write on my axes. And then now you get the idea, because let's say dot dot dot, between 98 and 99, where am I going? I'm going like up here, which is 2 to the 99. Right? Okay, so you get the idea. Right, you get the idea. Okay, so what do I do now? Well, I add up all the areas of these rectangles. Yeah, the width of the rectangles, as you can see, is always 1. Yeah, the width of the rectangles is always 1, but then the height of the rectangle changes. Okay, so we have a series, right? So it's 2 plus what? Plus 2 squared plus 2 cubed, and so on, so on, so on, until 2 to the 99. Yeah, so count properly. Yeah, you need to make sure that the last one is 2 to 99. Okay, then what? Then you know how to add this. Right, because this is just a geometric series, right? So, using the formula, what's my formula? A r to the n minus 1 over r minus 1, right? So, what's my a? 2. What's my r? 2 again. What's my n? 99 minus 1 over 2 minus 1. Okay, what does that give me? That is 2 to 100 minus 2, right? I just expand the brackets on top. The denominator is just 1, right? 2 minus 1 is just 1. So, therefore, I would have f as my final answer. Alright, so always draw the graph, always.